Hey, also, so far we've talked about the difference between a concave and convex polygons. We've talked about angles in convex polygons. And then we've talked about what it means for a convex polygon to be a regular polygon. And we talked about a bunch of different names of polygons. And so today we're going to focus in on one group, one family of polygons, the quadrilaterals, the polygons that have four sides. And specifically today we're going to talk about sort of like a subgroup of those quadrilaterals that we call parallelograms. So quadrilateral is any polygon that has four sides. And then we can split those into different categories. Today we're going to talk about parallelograms, and the next lesson will be about trapezoids, so we'll sort of leave this side undone. There's another family called kites, but we are not going to talk about the kite family this year. So a parallelogram you probably have seen and talked about and know about already is a special type of quadrilateral. What makes a parallelogram is that the opposite sides are parallel, and we'll talk more about this later on. So those two sides are parallel, and those two sides are parallel, and that's where it gets its name. And also the opposite sides are congruent to each other, so those two sides and those two sides. So this is what makes a quadrilateral, that's a hard word to say, a parallelogram. And so then parallelograms can take different forms based on special characteristics, which we'll get into in a minute here. So a parallelogram can be a rhombus, and that's, if you notice, it's basically a parallelogram where all the sides are the same size. Or it could be a rectangle. A rectangle is a parallelogram with four 90-degree angles. And then if you sort of like put the rhombus and the rectangle together, we get a square. All the sides are the same, it has four 90-degree angles. And so these are all shapes that we've talked about before, but we're going to talk specifically today about the special characteristics or properties that they have. And so if you look at this tree, it's important to know that any property a parallelogram has, a rhombus has that property, a rectangle, and so does a square. Any property that a rhombus has, a square also has. Any property that a rectangle has, a square also has. So a square is, it's a regular quadrilateral because all the sides and angles are the same. And it's sort of like this combination of all the different parallelograms put into one. So let's talk first about the sides. I mentioned on the previous page that in parallelograms, the opposite sides are parallel and they're also congruent. So you can build sort of a chart here. So opposite means across from. So these two sides with one arrow or one hash mark or tick mark, those are opposite sides, and they're going to be parallel, and they're also going to be the same size. They're congruent. And then these two sides, opposite, parallel, and congruent. In a rhombus, those two things are also true. And furthermore, as I mentioned on the last page, in a rhombus, all the sides are the same. So opposite sides are the same, but they're all the same as each other. So if one side in a rhombus is 3 centimeters, all the sides in that rhombus are 3 centimeters. A rectangle also has the same properties of a parallelogram: sides, parallel, and congruent. And then the square has all of these properties. Opposite sides are parallel, opposite sides are congruent, and all of the sides are equal. And so at this point, a parallelogram and a rectangle have the same properties for their sides. So we need to know more about it to determine that the parallelogram's a rectangle. A rhombus and a square have all the same properties of their sides. So we need to know something more about the shape to determine if it's a square or a rhombus. So that's when we assess the angles. So in any parallelogram, the opposite angles are congruent. They're the same size. So here I have these two angles opposite from each other. They're the same size. These two angles opposite from each other are the same size. Consecutive angles in parallelograms are supplementary. They add to 180 degrees. So what I mean by consecutive is if I start counting or looking at the angles starting here, if I go around in a circle, I get to that angle next. Those two angles are consecutive. If I added their measures in a parallelogram, they would add to 180 degrees. That angle and this angle are consecutive, they'd add to 180. This angle here and this angle here are consecutive, they'd add to 180. And so on and so forth. That one and that one, consecutive, 180. So that exists in a rhombus as well. So the thing that makes a rhombus different than a parallelogram was its sides. All the sides are the same size, but the angle relationships that exist are the same in both of them. Those two angle relationships exist in a rectangle, so opposite angles are congruent, 90 and 90, 90 and 90. Consecutive angles are supplementary, 90 plus 90 is 180. And then, of course, the property you already knew was all the angles are 90. So the thing that makes a rectangle truly different from a parallelogram is that all the angles are 90. And of course, a square has all those properties too because it has all the properties a rectangle does. Opposite angles are both 90. Consecutive angles are both 90. That add to 180. And then, of course, they're all 90. So the thing that makes the square unique is that all the sides are equal and also all the angles are equal. And the last thing that we talk about when we talk about properties or characteristics of parallelograms is their diagonals. If we connect the opposite vertices, so if I connected that vertex and that vertex, I get this segment called a diagonal. Same thing if I connect that opposite vertex with that one, I get a diagonal. In any parallelogram, the diagonals bisect each other. So that means this diagonal between the two yellow vertices makes two segments, that one and that one, that are the same length. This segment and this segment are the same length. And of course you can see that by the tick marks I put on there. So that's also true in a rhombus, but what makes a rhombus unique is that the diagonals are perpendicular and therefore they make right angles. So those four angles on the inside are right angles since this is a rhombus. In a rectangle, the diagonals bisect each other, but what's also unique about them is that the diagonals are congruent. So all these four little pieces end up being the same size because this diagonal in green and that diagonal in purple are the same length. And since they bisect each other, all these little pieces are congruent. And you might notice that we create some isosceles triangles here. Triangles that have two sides that are congruent. More on that later. And so then, of course, the square has all of the properties. The diagonals are congruent. They bisect each other, so all the little pieces are congruent. And then they are perpendicular just like a rhombus, and all those angles inside are right angles. So that's all I have for you today. I knew that was going to be kind of a lot of properties to write down. We will practice using those properties in class, so we'll use the properties to determine what type of parallelogram we're looking at. We'll use those properties obviously to write some equations and solve for x. We always like to do that. So if you have any questions about any of these parallelograms, make sure you're ready to ask them in class.